All right, my wonderful students, welcome back. Today we're going to talk about some different things with exponents, radicals, and equations. So kind of a little hodgepodge of stuff. But first thing we'll do is add and subtract radicals. We've done multiplication and division, but are yet to do adding and subtracting. So first things first, in order to add and subtract, you must have the same root. And you must have the same number under the root. So your problems that you're doing, you'll either have that scenario or you'll have some roots that you can simplify so that they are that scenario. Sometimes if you just have two different roots and they can't be simplified, you just can't add or subtract them together. Kind of like if you had an x variable and a y variable. Those are not like terms, so you couldn't combine them. So just a refresher, we have some perfect squares here, 1 through 13 squared, and then perfect cubes, 1 through 5 cubed. You need to know these numbers like the back of your hand, so make sure that we are keeping those on the top of mind. So first things first, I have 4 times the square root of 27 minus the square root of 75. These are not the same root. They're both square root, but I don't have the same number under the root. However, we can simplify some things. So 27, let's try to think, this is, I want to have perfect squares under there so I can simplify. 27, can I split that into factors so that 1 or more are perfect squares? Yeah, I think 9's a perfect square. So let's split that into 9 times 3. So this is really going to become 4 times the square root of 9 times the square root of 3. The square root of 9 is really just 3, so I have 4 times 3 on the outside, which is 12 square root of 3. And that is going to be the most simplified I can do. 75, what perfect squares go into 75? Well, 25, right? This is 25 times 3. So I can rewrite minus square root of 25 times the square root of 3. Square root of 25 is really just 5, right? So I'm minus 5 times the square root of 3. And now this is where we want to be. Like you'll notice I have the square root of 3 and the square root of 3. You can do operations with those as if they were variables, right? So pretend like that's 12x minus 5x. Well, we would just subtract the coefficients, right? So when I subtract these, 12 minus 5 is 7. I'm left with 7 times the square root of 3. Cube root's going to work the same way. As long as these are both cube roots, I can attempt to combine them. Perfect cubes are up here. So 16, let's see, 8 goes into 16. So I can split that into the cube root of 8 times the cube root of 2. Plus, I have a 3 on the outside. Don't forget that. 54, well, that's 27 times 2, right? So cube root of 27 times the cube root of 2. Back to the beginning here, cube root of 8 is 2 times the cube root of 2. This is plus 3 times cube root of 27 is another 3 times the cube root of 2. So this is really 9 here, 9 cube root of 2. So 2 plus 9 gets me 11 cube roots of 2. Bam. All right, let's see. Actually, I think you guys are okay with that last one. Very similar problem. Let's go down to rationalizing the denominator. Okay, so rationalizing the denominator, we are not allowed to have any roots in the denominator. If we do have that scenario, we do a process called rationalizing the denominator. So this says strategically, we're going to pick something depending on the scenario to multiply the top and bottom by, and when we pick the right magical thing, that root is going to be eliminated. You'll still have a denominator, but it won't have a root in it. So first things first, the easiest type is if you just simply have one square root on the bottom. So I have 1 over the square root of 6. We want a perfect square under that root. 6 is not a perfect square. However, if I had, let's multiply by the square root of 6 over the square root of 6. By doing this, now I have, on the top, I have the square root of 6. On the bottom, I have the square root of 6 squared. Well, when that's the scenario, the square root and the square offset, and I'm just left with the square root of 6 over 6. Okay, so your goal is to multiply by something on the bottom that's going to give you a perfect square underneath. Let's take a look at, this is a little trickier, the next one, the cubed root of 3/4. First thing we want to do, let's separate that into two roots. So the cubed root of 3 over the cubed root of 4. Cubed root of 3 over the cubed root of 4. So let's take a look at our perfect cubes. Those are a little trickier. So perfect cubes, 1, 8, 27. I think I can multiply to get that to be 8. 4, if I just multiply it by 2, will be 8. So what I want to do here is multiply the bottom. You always want to multiply by whatever number under the same root. So the cube root of, and I want to multiply by 2. Well, anything you do on the bottom, you're going to do to the top. So same process up top. Okay, let's simplify this real quick. The numerator is going to be the cubed root of 3 times 2 is 6. The denominator, the reason I picked the cube root of 2 is because now I have the cubed root of, and then 4 times 2 is 8. Well, that's a perfect cube, right? So this is really going to simplify to just be 2 under here. So I have the cubed root of 6 over 2. I got really excited there. I almost said under, and then I recovered and said over. Okay. Last type of rationalizing. This is going to be similar to when we had complex numbers on the denominator. You'll remember we had this thing called the conjugate. Okay, conjugate. It's the same expression, but flip the sign in the middle. So if you have more than just a root on the bottom, like on this one I have another term, I have that too, we're going to multiply by the conjugate on the top and bottom. Remember, you can only ever multiply by 1 here, so it's got to be the same thing over itself. Don't make the mistake of assuming the denominator is going to be gone. We need to distribute, and what you'll see is those middle terms are going to cancel out. So let's do the denominator first. 2 times 2 is 4. Then I have plus 2 root 5. Then I have minus 2 root 5. You'll notice those are canceled because they're the same terms with opposite signs. And then negative times positive is negative. Square root of 5 times the square root of 5 is 5. Denominator, you need to distribute. So I get 6 plus 3 root 5. Do not start canceling things. There's no factoring going on here, so we can't cancel. These two middle values are the same as 0. So I have 6 plus square root of, I need a 3 in there. 6 plus 3 times the square root of 5 over 4 minus 5 is negative 1. And then we can just divide each of those by negative 1. Got it. I'm going to set this next one up for you, but just in the interest of time, I'll let you do it. Even if there's 2 roots, still the same process. You'll multiply by the conjugate, so square root of 7 minus square root of 5 on the top and bottom. And I'll let you try that, and I'll have that worked out on the key along with all the practice problems. Thanks, guys.